Hello, everyone. I'd like to welcome you to our next class. Earlier in the semester, we actually did integration of the function e to the minus x. And when we did that, we used Monte Carlo integration and the stone throwing method. Here we're going to rewrite that, change it up. We're still going to use Monte Carlo integration because it's a time-consuming calculation. But we're going to show how we can speed up this calculation by using threading. So threading allows us to make use of multiprocessor computers. So we're going to send processes out to different cores on all the processors. This will allow us to speed up the calculation. There is time involved in creating threads and monitoring them, and so the speed up isn't directly related to the number of cores and threads, but it will speed up the calculations significantly. All right, so I've already gone and created an application that I called integration threaded and populated it with a few stubs, operators that I like to use, and additions to the array functions so that they'll calculate a standard deviation and a mean of the values in the array. But let's go ahead and get started. So the first thing we want to do is click over to Storyboard. So we know we're going to need a button to create the calculation and start the calculation. So I can throw a button in here and integrate. All right. Going to need text field, put that there. Gonna have a label, and we'll probably need a few of these. All right, so the first one will be the number of iterations that we want to run our loop. We'll have the number of guesses. And then we'll have our integral. All right, that seems like a reasonable start. So now we'll wire these up to our view controller. So we have a number of iterations, number of guesses, and then the integral value, and then we'll wire up our button. And we'll call this start the integration. All right, now I can close this. All right, now we'll probably need to have some variables for the class that hold everything together. So we'll need integral, set that to 0.0. Var iterations equals 0.0. Our total guesses, because that will ultimately be the number of guesses versus the number of iteration. Our guesses equals 0.0. Error, just in case we want to compare it to the exact value. We'll need to know the number of dimensions integration, which in the case of e to the x or e to the minus x will be 1. The exact value, in this case for the integral, of e to the minus x from 0 to 1, the exact value will be negative exp of -1 plus exp of 0 there we go. And for right now, that's about all we need. So if we come down here to start the integration, the question becomes, what do we need to do? Well, currently, so far in class, every time we've started a calculation, we have really blocked the main thread. And so every time we run a calculation that took any length of time, as the thread started, everything froze up and we got the spinning rainbow cursor. So that's not necessarily a good way of actually operating. You don't want to block the computer from doing everything. So instead of starting this as we are, let's force it to use a different queue within the system so we can basically allow other processes to still continue. All right, so if we go DispatchQueue dot global, and this tells us put it on a global queue available to everything, and it would help if I spelled it wrong, and it's still spelled wrong. There we go. And then we have to give it a priority, effectively. And so that's basically a quality of service. And we're going to say it's going to be a user initiated, which is one of the highest priorities that we could give it. And then we want to make sure that this runs asynchronously. So by running it asynchronously, it will spin this off into a different thread to be run, and then it will continue beyond. So that gives us an interesting problem. So we can put whatever code in here that we would like to see run, and then I'm going to put out a little print statement here that says print done. And we'll create a new function down here. And we'll call this function integration. Right now I don't know what I need to have in it, so we'll put nothing. And right now I'll just have this run a loop for I in 0 to 1,000,000. And we'll have it do nothing. Or we could do this. Var total equals 0. We'll just sum them up. So we'll say total plus equals double dot I. Now then we can come here and say print the calculation is done. With value equal %d, and then we'll print out total. All right. So now we should be able to go ahead and run this. Oh, it would be good if we called integration. Probably wants me to have self in there, so we'll call self.integration. So now we'll compile and run. The dreaded I'm compiling joke. Move the window up here. I don't really need to put anything in for number of iterations, guesses, or the integral, but I'll hit integrate. Now, if we look what happened here, it printed out done before the calculation was done. And that's because the instant I set this off into a new thread, it was going to continue applying whatever beyond that, the code that was beyond that statement. So this is going to continue on and execute. So if I needed the results from my calculation before doing this next object, I would have to do something else. And we're going to look at ways of doing that in a little bit. But just be sure that when you are doing something like this, that you allow yourself time to wait for the calculation to be ready, or to have a callback function or something that lets you know that the results are done and can be now utilized. And again, we'll talk about that later. So print done, fine. Eventually, though, it does do the calculation, and it prints out the value. Yeah, that's a big number. A lot of zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's like 500 billion, 500,000 or something. Anyway, lovely. So this works. It doesn't block, and that's a good thing. It doesn't calculate the integral that we want, but that's fine. We can move on now and deal with that. All right, so right now we just sum these values. That's not terribly useful right now. But we can do the same thing down here. So in the integration, we can have a variable that is integral array. And we can make this an array of doubles and initially leave it unpopulated. And now we can set up another dispatch queue. Again, we'll make it a global. And then we want our quality to be user initiated. And we'll say dispatch queue dot concurrentPerform. And this gives me an iteration and code that I can execute. So I need to tell it the number of times that I want it to iterate, and I have that value up here as iterations. So I can put iterations in here. Now I don't know what value iterations actually is at the moment. That's a bit of a problem. So I do have to get what value iterations is actually going to be. So if I want, I have to put in iterations int here. So I'm going to have to pass in a value for iterations. That could be iterations. And I have to have some value. Well, it should make this the iterations. And I'm going to say the iterations equals number of iterations dot int value. And I did not need to put that inside the brackets. And just so I can, I should actually make this iterations, not be a double. Well, we can leave it as a double, that's fine. And then to keep everything consistent, I'll say iterations equals double the iterations. And that needs to have length. All right. Oh. Yeah, you'd think one of these years I would learn how to spell. Fortunately, the compiler tells me all the dumb errors I make and allows me to fix them. Okay. Fine, we can just make that in 32 down there, and that should be fine. Yeah, but that wants to be an int. Okay, fine, we'll make that an int. All right, so now the code that we have to perform has to go in a closure. So I will put in a bracket for the execute. So now this concurrentPerform acts as a for loop that will run a number of iterations and has to have a set number of code. Now, in the execute, we basically have to tell it what we want it to actually do. And so we'll say for index in whatever we're going to do. And in this case, let's print started index just so we know what is actually going on. And then terminated string arrow. There we go. All right, so print started index, and then we're going to calculate our integral. So we'll say integral array dot append, and we'll want to basically return our calculated Monte Carlo integral. Calculate Monte Carlo. Calculate Monte Carlo integral. And we'll need some things to pass into that. So we know we'll need the dimensions. And in this case, we'll go ahead and just pass in the value of 1. And we'll probably need the number of guesses. And for that, we'll need to pass guesses into the function. Probably be an int 32. So we'll pass in guesses there. So coming up here, I also have to pass in guesses. So I'm going to let my guesses and what did we call that? Number of guesses. And we'll take the int value there. Pass in my guesses. And it's telling us that we still haven't created a calculate Monte Carlo integral, and that's mainly because we haven't set up a calculated Monte Carlo integral. Come down here and go function calculate Monte Carlo integral, and we know it's going to need dimensions, int, and guesses, int 32. All right. So we have that going now. And then we have to return a double from that. All right. So right now I'll just say return 1. That'll fix that error message so I don't have to keep looking at it. All right, so if we get down to this integration, it's going to create an array of integrals for each iteration that we were going to go through the calculation loop. And so now we want to calculate the Monte Carlo integral. And so to do that, well, let's continue with this first. So the question is, what do we have to do in order to get the true value of this integral? And so now I have to move outside of the concurrentPerform call. So I need to look where these are closed. That closes there. That closes the DispatchQueue. So out here, but still within my function, is where I want to start. And so I'm going to create a volume, let volume equals 1.0. Now here I'm cheating because I know I'm calculating e to the minus x from 0 to 1. So the width of my box will be 1 because 1 minus 0 is 1. So this isn't a good thing to do, but this is just for an example. And then I'm going to need to have a new variable. This will be an array. Now this array will actually hold not just the sum of all the points, which is what integral array is holding, but the actual value of the integral, because here we'll divide by the number of points and the multiply by the volume. And here the volume's 1, so technically it's not really doing anything, but it's the correct way to do that. And to do this, we'll go integral array dot map. And so the map function is going to allow us to operate on every element within the integral array. And we're going to take the element in the array, each element that's returned, and multiply by the volume divided by the double value for guesses. Now that we have the integral value, we can take the average of these values to get an approximation more for what the integral actually is. So we're going to say integral is equal to integral value dot mean. So mean is one of these extensions to the array that exists in this class, array standard deviation Swift. And this will give me the value of my integral. So if I want, I can print this out. So I can say print integral is integral and that's fine. Since I actually have integral belonging to the class, I'm going to rename this one. I'm just going to go let my integral, and I'm going to rename this as my integral. Okay. Keep things safe. Yep. And then we close that. All right, integral value. No, that shouldn't be integral. That has to be integral value. There we go. That's why I still have that error message. All right, fine. Now that I've got my integral, I want to actually display it. Now, all interactions with the user have to occur on the main queue. So I have to go DispatchQueue. Now, everything that's happening here outside of the concurrentPerform actually waits for the concurrentPerform to actually finish. So my DispatchQueue down here will only be executed after I run through all the loops and have done all the calculations. So I have my new DispatchQueue that has to be run on the main, and I want it to run asynchronously on the main. And what I want it to do here, I want it to say self, and I want to put in integral value, double value equals my integral. I want self.integral to be equal to my integral. Because it's async. Oh yeah, spelling in real time is not my strong suit. Okay, now great. So we made good progress here. This should update this. We just need to calculate our integral. So how do we go about calculating the integral? Well, this is going to use the mean value theorem, and it's basically going to take guesses between 0 and 1. And it's going to update our functions. So we're going to go here. And our main function will be e to the x. Sorry, we're doing e to the minus x here. So we'll put in a var current integral. Equals 0.0. And I'll have a loop that goes for I in 0 less than guesses and here we will want to calculate e to the minus x, so that will be exp. Oh, no. Oops. Yeah, gotta get our random numbers. All right, so we'll say let x equal double dot random in 0 dot 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 1.0. That has to be 0 to be a double. All right, now we want to calculate current integral plus equals exp of minus x. Okay. Then we want to return current integral. So that will calculate a double, selecting some value from 0 to 1, calculate e to the minus x, and add it into integral. We return that. Now, we didn't really need dimensions in this case, but if we wanted to extend this to do a higher number of dimensions, so what we should do is actually check if dimensions equals 1. Then we should do this calculation. And else we should actually print an error. Else print mismatch in dimensions. That's good. All right, return current integral. So let's see what happens if we run this. So let's give it 10 iterations, 1,000 guesses, and hit integrate. And it prints out our integral is 6.278. That's actually quite reasonable. Now, if we notice, it actually returned fairly quickly, and it printed down here our starting index values. 1, 0, 7, 6, 2, 4, 5, 3, 8, 9. So it doesn't start each thread in a predictable order, and it won't be the same order every time. So I can hit integrate again, and this time we got 0, 1, 2, 5, 3, 7 compared to 1, 0, 7. So you can't count on which direction something was going to be. Our value is 0.6278, 0.632. If we wanted to, we could come back in here and exact is self.exact. Recompile it. 10 iterations, 1,000 guesses, integrate. And again, we get 6.28 versus 6.32. So if I want to improve this, I can increase the number of guesses. Now again, instead of blocking this, I can now still copy paste in here. And so this is the advantage of running this asynchronously in the dispatch queues. So here with 358,000 guesses roughly, my integral is 6.322 versus 6.321. So we now have a working integral. Works very well. However, it only works for e to the minus x, and it only works for the range 0 to 1. I can't change that right now. But this is a good spot to stop for today, and we will continue for the next lecture on how to improve this to make it more useful and more utilizable. So with that, I'd like to thank everybody for watching, and we'll see how to do this a little bit better and extend this program next time.